So, in the real number, we are going to be study the second one, the concept that is a prime factorization. In the prime factorization, we are going to be find out the highest common factor and the least common multiple, that is LCM. That steps how to find out for the prime factorization method to find the HCF and the LCM. The first one is what? First find all the prime factors of the given numbers. That I let you know that how to find out, how to write the all the prime factors or the prime multiple numbers. Okay. The second one, the product of, that is for the only HCF, the product of least power of each common factor among all prime factor is your HCF. That is the product of least power of each common factor among all the prime factor is your LCM. That I let you know while solving the, how to find out for the, or how to identify the HCF and how to identify for the LCM. The product of the greatest power of each prime factor in the number is required your LCM. So the product of greatest power, the greatest power of each prime factor, the greatest power that I let you know while solving the example, that is your LCM. Okay. So the first one example, that how to find the LCM and HCF of integers by expressing them as the product of the primes. The first one I have taken the example 12, 15 and 30. So by this example we have to find out the LCM as well as the HCF. Okay. So first one is the 12. How to write the multiples of the 12 by using the prime numbers. Okay, if I take the 12, so the first one, the 12 is going to be divisible by again the 2 ones are 2, so 2 6 are 12, that is again 0. So again the remaining is what here, the quotient is 6, that is again by taking the 6, again 2 3s are again 6, that is again 0, up to the 1, up to the 1, the quotient is up to the 1, we have to be divisible. So your these numbers are your the prime multiples. So again 3 is again divisible by only the 3. So here we have get, that is up to the quotient is 1. So the multiples are 2 into 2 into 3. That is 2 into 2 into 3. That is 2 to the 4. 4 3s are 12. So likewise we have to find out for the what, the 15. 15 is having the prime multiples is like 3 into 5. For the 30, that is 2. That is 3 into 5. Okay, so 2 3s are 6, 6 5s are 30. So or else you can follow these steps to find out the prime multiples of the 15, prime multiple as the 15 and the 30. Okay, so here how to find out for the HCF. What is mean by the HCF? The product of least power. So here we have the common multiples. What we have the common multiples among the 3, that is 3 is the common multiple. Here we have the 2, only the common multiple for the 12 and 30, but not for the 15. So we are not going to be choose the 2. So we should have the all the common multiples for the given numbers. That is 3 is the what? Common multiple. So HCF is how much here? That is 3, and it should be highest common factor among these. Okay. Then how to find out for the LCM? LCM is what? The greatest power of each prime factors. So here we have the greatest power like that. We can write this one as the 2 square into 3. So this one is as it is, that is 3 into 5. This is also as it is 2 into 3 into 5. So is the in the multiple of 2, the highest power is how much here? 2 square, and the remaining numbers are how much? That is here we have the 3 and the 5. So 3 into 5, that is 15, 15 4s are 60. So the LCM of that is 12, 15 and 30 is 60. Okay, so the next example again we are going to find out for the what? The prime factorization. Okay, so we have to find out for the what? The LCM and HCF of integers by expressing them as the product of the primes. Okay, for the 18, again 18 we can write this one, it as the what? This is again divisible by the 2. Again only we have to take the only the prime numbers here. 2 9s are 18, again 0, again 9 remain in the quotient. Then 9 is going to be divisible by 3. 3 is a 9. We have to do up to here. The quotient will be the 1, that is again 0. Again 3 is going to be divisible by the again 3. 3 ones are 3, that is again 0. So we can write the multiples. The prime multiples is like 2, product of prime multiple is like 2 into 3 into 3. That is 2 into 3 into 3. We can write this one as the 2 into 3 square. So commonly we know the 81 will come in the multiple of, that is 9 into 9. That is 81. We can write this one as the 3 square into 3 square. So for the 108, again we are going to be find out how to find out for the 108 is, this is a very simple. That is 108. Again it is divisible by the 2. That is 2 5s are 10, 2 4s are. Okay. So 2 5s are 10, 2 4s are. That how much remains here? Again how much here? 54. So 54 is again divisible by. Here we have the quotient is like the 54. 54 is again divisible by the 9. Sorry, 9 will not come because 9 is divisible by. So again here the 54 is divisible by the, again we have to use the only prime numbers. 3 1s are 3, the remainder is 2. Again we are going to be carry forward the 4. Again 3 8s are 24. Again the remainder is 0, but here the quotient is again 18. Again we have to take only the prime numbers. That 18 is going to be divisible by again 3. 3 6 is 18, that is 0. Again here the quotient is 6. Again 6 is going to be divisible by, again we can take the 3. 3 2s are 6. Again 0. The quotient up to the 1. Again 2 is going to be divisible by itself. That is again the remainder is 0. So the multiples are what? 2 into 3 into 3 into 3 into 2. 2 into 3 into 3 into 3 into 2. It means we can write this one as what? 2 square into 3 cube. Then how to find out for the HCF? That is mean by the HCF here. That is least power of each common factor. So here is the least common factor. Okay, so that is what? The least power of each common factor. So here if we take 2 is not coming the common multiple in the 81, so we leave. So here we have the 3 square, here we have the 3 raised to 4, here we have the 3 cube, because 3 square 3 raised to 4 3 cube. So least power of the common factor. So least power is here how much? That is 3 raised to 2. Next, how to find out for the LCM? LCM is the highest power. Highest power is here we have 3 raised to 4, and the remaining numbers are 3 raised to 4. Then it is 2 square. This is what? The LCM of the 18, 81 and the 108. So in this exercise 8.2, they have been asked, express each number of product of its prime factor. Express each number as product of its prime factor. So we have to write in the multiples of the prime factor for the 140. But how to find out the product of the prime factors for the 140 is, so first we choose the number 140. So the least prime factor is, that is 2. Again 2 7s are 14, the remainder is 0, again 0. So the again quotient is 70. We have to only use the prime numbers. So 70 is divisible by again 7. 7 10s are 70 is again remainder is 0. Again the quotient is 10. Again 10 is divisible by the again 5. 5 2s are 10. Again the quotient is 2. Again 2 is going to be divisible by only the 2. That is the multiple of the prime factors are 2 into 7 into 5 into 2. We can write the product of its prime factors as like 2 into 7 into 5 into 2, or else we can write in the form of 2 square into 5 into 7. In the next one example, we have to find out the product of its prime factor for the 156 is. So 156, again the list prime factor is 2, 2 7s are 14, the remainder is 1, again we take the carry 1, that is 6, that is 2, 8 is a 16, that is 0. So again the quotient is 78, that is it is divisible by the 13, 6 are 78, 0, again the quotient is 6 is going to be divisible by, again we have to only take the prime numbers here, 3 2s are 6, again the quotient is 2, 2 is again divisible by the only 2, that is 2, 0. So we can write the product of its prime factors are, that is 2 into 13 into 3 into 2. So here we have to write, that is 2 into 13 into 3 into 2. So this is what the product of its prime factors for the number 156.